Okay, so after that activity here today, we have lesson 3-1. We're going to talk about decimals and estimation. Which we've already talked about estimation already. Chapter 1, estimating fractions. Okay, it's not going to be too drastically different when we're estimating decimals. Now, however, there are two terms that we do need to recall to help us here. One of them, obviously, is estimation. Actually, we'll throw in the third there. Estimation, compatible, and rounding. You have to get the vocabulary correct in order to do these, because this is the whole lesson right there on the board. Estimation, compatible, and rounding. What was our definition of estimation in chapter 1? Anybody remember? Michael? It's a possibility. Why do you say to the nearest whole number? Okay, that is that's possible. Yes, that's not bad. Do you always have, I guess my question is, do you always have to move it to the nearest whole number? The answer is no on that. Well, estimation? Chase? Okay, you can do it by halves. Remember we said that this is an educated guess. Okay. And all of those are right. I mean, half, whole, maybe the nearest quarter. It all depends on the problem. What was our definition of compatible numbers? Grant, do you remember? Okay. Okay, change numbers so that you can easily compute them in your head. And when it comes to compatible numbers, are all of us going to have the same answer? No, not when it comes to compatible number. Okay, same thing with estimation. Okay, and then we threw in this rounding thing that throws everybody for a loop. Rounding, you have to know what? Rounding, you have to know your place values. Rounding is to a specific place value. When the questions ask you to round, will they give you a place value? Yes, they will. Will all of you have the same answer when it comes to rounding? The answer is yes. Yes. Okay. The other two, your answers will vary from each other. And that's okay. There's nothing wrong with that. Okay. But here's the confusing part. Okay. Knowing all of that information. Here would be a typical problem. Okay. Here's what scares me. There's a lot of words in there. Based on our reading habits so far, this isn't good. All right, so it says estimate 12 and 3/10 times 4 and 8/10 by rounding to the nearest whole number. And then on top of that, they throw in this word estimate over here. So you have estimate and rounding in the same question. Ouch. Because some of you might read that and go, I get to estimate. And we know based on what we've seen so far, you may stop reading. Not good. By rounding to the nearest whole number. Okay, so now you got to use your rounding rules. If we're rounding to the nearest whole number, what place value are we looking at in 12 and 3/10? Think about this. You're rounding to the nearest whole number. What place value are you looking at in 12 and 3/10? Grant. Very good, sir. You are looking at the ones column. And you are looking to the right to see if that is what number? What is it? 5 or greater. Well, you should. This is an elementary thing. Right? So it's less than. So what are we going to do? Round it down. Very good. Round it to the nearest whole number. Nearest whole number is 12. You could think of it as money. What's $12.30? Is that closer to $12 or is it closer to $13? Closer to $12. Okay, better to know your rounding rules, but you could think of it as money. Times 4 and 8/10. What number are we looking at? What number are we looking at? The 4. What place value is the 4 in? The ones. Look next door. Is that 5 or greater? I got to round up to the nearest whole number. $4.80 is closer to $5 than it is 4. Okay, and when we complete our answer, you all should have 60. There is no estimation here, even though it says estimate. but it also gives you directions of rounding to the nearest whole number. You see how the directions can be a tad bit confusing using both estimation and rounding, right? Okay. Number 2. Okay, what's the only difference between number 1 and number 2? Mason? Okay, you're dividing. Some of you will overlook that part. Okay, the only difference is that symbol. Everything else stays the same. Yes, you have to look at the operational symbols. Okay, what are we going to estimate 62 and 9/10 to be to the nearest whole number? Zach. Helps when you pay attention. What are we going to estimate to the nearest whole number? 62 and 9/10. Three? Oh, I can't hear you. 63 divided by 7 48/100 to the nearest whole number. Grayson. What is 63 divided by 7? That'd be 9. Okay, this is not difficult. However, the wording is going to get in the way. So far, so good. Okay. Try these 2 on your own.
Teachers, please excuse this interruption. Just a real quick announcement. Students, I want to make sure that we are staying vigilant with wearing masks. So please make sure that you are continuing to wear your mask as directed by your teachers. And remember, wearing your mask, you should be covering your mouth and your nose. So please make sure that we're staying with that. Again, we want to make sure that we are taking care of business so that we can continue to be in person. We want to make sure that we're staying vigilant with that. So once again, please make sure that we're continuing to wear masks, covering our nose and mouth. Thank you very much. Have a good day.
All right, go ahead and do those 2, please. The directions are up at the top. Okay, what did we get for number one? What's our two numbers, Jen? All right, that is correct, sir. Rounding to the nearest whole number. Everybody should have 16 times 3 is equal to 48. Okay, Cole, what'd you get for number two? I heard 27 times is, what is it? Okay, everybody should have that. So far, so good. Okay, now the rules change. Okay, let's talk about this. Use compatible numbers. Probably should put an S on there. To estimate 48 and 97 hundredths times 3 and 91 hundredths. Okay, what does compatible mean? I go. Okay, so if we were correct, we'll get to that in 1 second. If we were still doing what we were doing, hopefully you're paying attention here up on the board, we would get something that looks like this. Right? That would be doing what we were doing, meaning we were estimating or rounding to the nearest whole number. Okay, is 49 times 4 easily computed in your head? No, it's not. Not at all. Okay, so again, you got to read the directions that are given for you. Now, compatible numbers is exactly what Michael said. We are going to change so that we can easily compute in our head. Now, watch this. So what if we did this? Okay, well, let's think about that. We changed them. Is that compatible numbers? Yeah, I would agree with you. It's not. 49 times 5 is not easily that we can do in our head. How about this? How about this? Okay, I would. All right, very good. I'm glad somebody said that. Yes, this is a lot better than this. Now, I probably would not count 50 times 5 wrong, but what have we always talked about? When you use compatible numbers, you want to stay close as you possibly can to the original numbers that are there. Okay? Again, I would probably not count 50 times 5 wrong because that's fairly close. Okay? But I do agree with you that 50 times 4 would be the better answer. Okay? We can easily get that 200 thing in our head. Okay? 200, 225, or 250, it's not bad. Does that make sense? Right? Okay. So the only thing here, again, we're multiplying and dividing. okay, what kind of compatible number do we want to use for 62 and 4500s? Now, when you do compatible numbers, I would highly recommend that you look at both of the numbers. Okay? And again, you got to know your facts. I mean, this is what this comes down to. Knowing your basic facts, whether you're multiplying or dividing, especially dividing. Okay, what do we want to change 62 and 4500s to be, Kayon? Okay. I would totally agree with that. You can easily do that in your head because you know that 12 times 5 is 60. Okay, it's tempting to go 63 maybe because it's, but you got to get that rounding to the nearest whole number thing out of your head. It could work at times. It's possible. Okay. Michael. 60 divided by 10. Yes, I would accept that answer. I probably would. Those are probably the only two that would work. Okay, because that's relatively close. You're 1 and 7200ths off the original one. But again, all I can emphasize is try to stay as close as you possibly can to the original numbers in the problem. Okay, because they're giving you those numbers for a reason, to stay close to them, right? You don't want to stray too far away from them. Yeah, you don't want to go too far away. Okay, you're correct. Okay, so I would say if you're within, depending on the numbers, 1 or 5, if you're multiplying, possibly 10, you're going to be in good shape. Okay, and we've already talked about compatible numbers back in chapter 1 too. All right, let's try a couple. All right, what do we get for number 1? What are your compatible numbers for number 1? Emma? Okay. 40 and 10 will give us 400. I would agree with that. Okay. It's possible you could do, right? You could do anything times 10, right? You should know your multiples of 10, correct? Those are all good. Okay, even 38, I guess, right? If you went down. I'm good with that. What about the bottom one? Chen? Okay, 140 divided by 20 gives us 7. Very good. Okay, now I'm not sure that there is another one for number 2. That's pretty good right there. I mean, that's as easy computing in your head as you could get. Okay, I wouldn't go 135. I would try to get multiples of 10. I would try to get multiples of 5 when you change your numbers. Okay, so the takeaway here today is you need to read the directions carefully. Okay, whether you're rounding to the nearest or you're using compatible numbers or you're estimating. Okay. All right, the homework for lesson 31. We're going to do 3 through 41, the odds.